Okay, welcome back. We're talking about the security authentication plugin modules, so you don't have to use the built-in stuff. Kerberos is one that you may have heard of before. It's a fairly robust system designed specifically for networks, which is great because that's what we kind of are lacking here. The other one, you can actually go in and get an NTFS version. So you can have like the file system formatted like NTFS and have NTFS permissions and group policies and the whole shebang. Basically, just make your Linux box look like a Windows machine. Pretty doggone cool. So, there's in addition to PAM, there's also another one called Modern Access Control on page 83. So lots of different distros. For example, there's one called SE Linux. Security Enhanced Linux comes with this built in. You don't have to go get this thing. The one that we're using is called App Armor, and so that's what's called a mandatory access control thing. And App Armor is sort of like, it's more analogous to like virus protection and making sure that if you type in a command that you got off the internet, it's going to block it, that kind of thing. Okay, so mandatory access control. It uses classifications, kind of sort of like, regular and secret and top secret. You give a classification to something and therefore it knows what kind of controls that you have to be able to do that. And then there's role-based access control. And typically the way role-based is supposed to work, role-based, by the way, role-based is the way you set up everything. In other words, typically you don't want to give permissions to an individual person. You want to give to what they do. So if I'm in the sales group, I give the permission to the group, not to Bob, but to the group. Kind of makes sense? And of course that would work a hell of a lot better if we had an add-on that allowed nesting of groups, which we're not going to do. Okay, we're ready to switch over to Chapter 4. Yay, Chapter 4! So Chapter 4 talks about process control. We went through this in the other book, so some of this is going to be kind of sort of the same. All right, so if you remember with the process command is one of those weird ones. I mentioned where there's no dash. So if I did AUX, right? There's another one, if I did PS, so there's one called LAX. Just different ways of doing the same thing. In fact, I'm going to go ahead and type this through last so you can see the headings. Okay. There's one called Axel, which is actually a pretty decent one. AXL. Okay. Well, that looks like exactly what I just did. Anyway, so the kernel, in other words, the operating system itself, not the commands, but the actual kernel, keeps track of all the address spaces. Okay? Who's using what chunk of memory? Because the operating system has to be the traffic cop. Okay? It's got to be the one that says, wait a minute, Bob, you have this chunk of memory and only you can do it. Oh, Sue, you have this chunk of memory and only you can see this. So it's a traffic cop. It holds on to resources and doles them out and makes sure that only the person they doled it out to have permission to be able to do something with it. Kind of makes sense? So it keeps track of address spaces and the status of a command, whether or not it's running or it's paused or those kind of things. Hey, by the way, don't I still have a paused? Yeah, I still have a paused command. Maybe we just started that tree command and I hit a Control-Z, so it's still sitting out there. That's pretty cool. What the priority is. The priority is a strange beast, and we're going to talk about that in a lot more detail soon. But the priority is, for example, system-related things that have to get done in a hurry, like clearly you're going to have a higher priority than some measly command that I type in. It's going to keep track of the owner and a bunch of other stuff that we've already seen. Okay, so I know this is getting a little geeky, but just bear with me. The difference between a thread and a process. If you've taken the prerequisite course on OS design, you probably know all this stuff. If not, it's okay. A process basically means that I've been given a chunk of memory and I have to stay within the bounds of that chunk of memory. Okay. A thread means I can take that and have break it up into multiple chunks so I can be running multiple things simultaneously. Now, I still can't exceed the amount of total amount of RAM that I've been allocated, but I can ask the machine, Mother, may I please have a little more? And then I can have 2 of those things running. Oh, wait, can I have a little more? And then I'll have 3 of those things running. So threads, a single process can have multiple threads. Now, when we use the PS command, we're not actually seeing the individual threads. We're only seeing the processes. There are other things you can use to say, show me everything to include the threads, but let's don't do that. Okay, kind of sort of makes sense? Okay, we talked about the process ID number. The PID, of course, is an acronym. First of all, they're unique and they're sequential. So if I did this, I'm going to do the AUX, and I'm going to type that through last one more time. Okay, so process ID 1 is the init because that starts everything. And then, I probably should have done the Axel one where it told the parent ID. I think I can just do that with just throwing the L in, I think. AX. Let's just try this with the L. No. Okay. Well, excuse me. Anyway, I was trying to show that the process ID, and then every process except for the first one has a parent process ID. So they're unique numbers and they're sequential. Oh, wait a minute now. They're unique and they're sequential. Couldn't I run out of process ID numbers after, let's say I had a machine running and it's been running for 5 years? Yeah, when it gets to the end of the number of digits that it'll fit, it'll actually go back and try to find ones that have expired, so to speak, and start reusing them. But that's a pretty rare scenario. So every process except for the very first process or 2. Process ID 1 and 2 are kind of the exceptions. But every other one has a parent process. Okay? In other words, all these guys have a parent. Let me try Axel again because I can't remember which one has the... There we go. Cool. Axel. All right. So the first 2 do not have a parent ID. All right. But all the rest of them have parent IDs. So if I scroll through, I'm going to hit the space bar. Scroll through, get down towards the bottom. Well, there's some sort of network thing that's using 100 as a parent process ID. Let's get down to here. So it looks like 24,776 is the parent of something. Okay. Now you can probably find my login. Okay, my login is the ID for my login is wow. That's weird. I'm not. It looks like it's 1873 for my login. Oh, there it is. Okay, yeah, 1873. And then down here, the parent is tree, and then the parent is PS Axel. So the parent ID for that guy is 1873, and 1873 is my guy. So anyway, that's how I can create that. Remember that PS tree thing we did, where everything has a root except for the top 2. Cool. The shell, in this case, bash, which is about halfway down the list. Bash is the beginning of my user space, and it has a PID of 1873. So all of my children should have a parent ID of 1873, and it looks like they do. Okay. Once again, they go over the thing about the process owner ID. The effective ID, which means effective ID is the one that's currently you're masquerading as, and then the saved ID is the one that you could go back to after you've finished masquerading. Okay. There's the same thing for group. I mean, you have a real group ID, and you have an effective group ID, and you have a saved group ID, because those two work about the same. Okay. The priority in a PS mentioned that system kind of commands, some system commands like responding to a request on the network, those things are very high priority things. where you piddling around typing on the keyboard is probably not near as important. So the system assigns priorities for the things it thinks going to happen. Now, after you've got the system applying a set of priorities, you are allowed to go in and tweak a few things, particularly those things that belong to you. You can change their priority. It's called nice. And what we're going to do is we're going to do one here in just a minute where we throw in the nice factor. So the nice typically is like, in this case, 20 is a relative starting number for a priority. 0 for a niceness factor. It looks like there's some minus 20s in here, which means, okay, I want to make this guy more performant. We'll talk about that in a minute because we're actually going to do an example. Okay, and then of course one of the things is the control terminal, in this case like TTY1, which is telling me where the thing is going, right? Now, not all processes have a control terminal, as you would imagine. For example, you know, the login thing. Well, the login thing it's waiting for someone to do something on a terminal, so it doesn't have a terminal yet. As soon as somebody types something in, then it will have a terminal. On page 93, you talk about the life cycle of a process. Now, this is something that's kind of weird. Now, just bear with me for a minute. Linux is kind of alone in the world in the way it creates a new process. The behind-the-scenes story behind this is crazy. But here's how I have a process, and then I want to create a child process. Instead of just saying, fine, okay, I'll just create a child, and doink, and now I have a new child that can go do stuff. That is not what it does. What it does is it creates a clone of itself. So it takes this, and then creates a complete mirror copy of that, dunk, and then you just throw away the parts you don't need. Kind of weird, kind of wasteful, but it was a pretty cool technique, and it's been around for quite some time. But it is a little odd that whenever they create a new process, it clone. The term is called fork. I fork a new process, and then after I forked it, I go in and strip out the things that I don't want and add the things that I do want. Kind of weird. Okay, now all processes are supposed to be kind of listening for their parent, because if their parent gets killed, then they need to be listening, right? So they can back, oh my God, my parent got killed, therefore I have to go too. But what happens if somehow the parent got killed accidentally or it crashed? And so I have these child processes out there that don't have, they're orphans now, okay? That don't have a parent. You've kind of broken the tree, okay? And the tree is not designed to be broken, okay? You cannot have broken parts of the tree. You can't have something just hanging out there that doesn't attach to the tree someplace. So that's not good. Now the system will periodically go in and find orphans, and if it finds one, it's going to give it a parent. It's going to say, we're going to adopt you, and the process that typically adopts it is the system D guy, the init at the very top. So if you have a broken tree and it finds an orphan, it's going to be adopted immediately by the root of the tree. Kind of weird. Okay, signals. We kind of talked about this a little bit before in the other book. So there's a bullet list on page 94, things you might want to use signals for. One is, I want to have one process talk to another process. So process number whatever wants to talk to some other process. The way you do it is one of many ways you could do it. You just send a signal back and forth. Say, hey, I'm ready for some more data. Okay, here it is. Give me some more. Okay, that kind of stuff, back and forth, back and forth. Keyboard commands. I mean, we've seen the Control C thing where the keyboard sent a signal to the process. Remember all that? Good. The kill command, we talked about that. How if you type kill, then we're sending a signal to a process to make it die. And then most of them are going to be, sent by the kernel itself, particularly like if it's an error. Or perhaps one of those things where the death of a child, the machine has discovered that a child has died, and so we send a signal to the parent saying, I don't know what the hell happened, but one of your children just died, which seems pretty macabre. Okay, we're coming up on 15 minutes.